Hello dear friends and welcome to another electronics video. Today we're going to build a great circuit. It's going to be a counter with Arduino and TinkerCad. So this counter is going to work in the following way. When you supply it, it will start counting the a number of seconds, minutes, hours, and days since it was turned on. This is a great first project if you're planning to work with your son or daughter to get them into electronics, and it's a great entry project into the world of electronics. So let's start by creating a new circuit. And in TinkerCAD, this would be the canvas where we're going to be importing all our components. And on the right side, you will see that you have the code and you have a start simulation button, just that we can see the code running in real time, which is very important for any electronics project, that it has a strong basis in reality. Okay, so let us take all components and search for a Arduino board. Arduino Uno R3. Let us place the board here. I'm going to rotate it a bit just that we get it in a good position so we can put an LCD to the board, and let's search for an LCD to display our um, our code. And what we would like to do is, here on the first line we can write like the time, the second, minute, hour, and on the second row we can write the number of days. This is a two row 16 column LCD. Okay, just that we do a good connection. So we can start with connecting the ground from these two boards. So we will take the ground um, from the LCD connected to the ground from the Arduino board. Then we're going to take the supply and connect it to the 5-volt power line on the Arduino board. Just that we supply everything from an Arduino. This is very good because you don't need an external power supply. You just plug it in an USB, and then it just runs and runs, and you don't have to do um, any additional power supplies just to power the modules. Then here we have a number of pins that the display has. The contrast is a pin that would create the contrast between the backlight and the LEDs lighting the letters or numbers or what we are willing to display on the display. So in order to be able to control this contrast, we're going to use a potentiometer, which is a variable resistor, and we're going to connect this potentiometer. Whoa, this is really big. 250 kilo ohm. We're going to put a much smaller one, let's say a 500 ohm potentiometer here. So this will allow us to control the contrast for the LCD. And now we need to plug this into the um, LCD board. So let me rotate this a bit. I'm going to connect one terminal to the ground, and the other terminal I'm going to connect it, uh, just that I center this, and the other terminal I'm going to connect it to the VCC. More about potentiometers you can find in our resistor video, where I explain exactly how the potentiometer works and the number of pins that it has and the function that it has. Okay, and then the contrast pin here, which is between the VDD, VCC or 5 volts and ground. Another very important part that we need to connect to the supply are the backlight LED. So for the backlight, we have two pins here, lead anode and cathode. And as we discussed in our Diodes Made Easy video, we need to supply the anode and connect the cathode to the ground. And also we need to limit the current that goes into the anode because we don't want to break the backlight for this LED. So in this case, let us take a 200 ohm resistor, just that we, not 1 ohm, 1 ohm is too little, 200, okay, and we just connect it to the anode. This has to go to the supply, so I'm going to take a weirder route for this. I'm going to go around the Arduino here, um, just that we don't cross wires through all the data wires here. And the second one, the cathode, we're going to connect to ground and also take this wire all the way up here. Just 1 second, and connect it to the ground pin. Great. So now we have connected the contrast pin. We have connected the supply, the ground, and the back LED. Let's see how this looks. So now you can see, yeah, you can already see, as we've discussed, this is a 2-row, 16 column LCD. So you already can see the component, and you can see as we're uh, calibrating the contrast, you can see here the back LEDs are lighting more and more as we change this potentiometer here. Okay. The next pin that we're going to connect is, or to make it a bit easier, let us go and stop the simulation and go a bit to the code side. So I'm going to use the block setting from TinkerCad. It's quite easy to understand. Um, Let me delete these blocks here and delete block. So it has two main states. On start, what happens when we start the Arduino board, and in a loop, I mean forever, constantly looping on and on. On start, we just need to initialize the LCD. So here is the configure LCD pin. Let me move this a bit to the left, and we're going to use a standard configuration for this. And you can see here already the pins to which we have to assign the LCD. So for the standard configuration, they say that you have to connect the RS or register select and the enable pin and 4 data bits, uh, 4 data lines. So then let us go from the left side. So take the register select and let's connect it to the first pin, pin 0 here. And then this is centered. And then the second one we have to connect is the enable pin. Let's connect it to the first. Okay. Great. And now we just need the 4 data pins, DB4, 5, 6, and 7. So let's look on the board. We have DB4, 5, 6, and 7. And now we have to connect them to the Arduino board. So let's use pin 4. 4, 5, 6, and 7. As the name implies, we're just going to use very similar pins. So I'm going to connect this to pin 4. Just move it a bit around. Pin 5. Connect pin 5 to pin 5. And then pin 6. Okay. This is not looking that great. Maybe I can do a bit of tailoring here later. And then pin 7. So this means that all the pins are getting connected. Great. So this means that we have connected also the pins. Now what we have to do is set these in code. So we have connected to the RS pin. We've connected pin 1, pin 0. So this is pin 0. To the enable, we have connected pin 1. Enable goes to pin 1 in the Arduino. DB4 goes to pin 4. DB5 to pin 5, DB6 to pin 6, and DB7 to pin 7. Great. Now, the first test is to see if the LCD works. So let's take the first piece of code, print on the LCD the text "Hello World." Let's see if this works. So let me push this back and click on the start simulation. And we have the word "Hello World" written. And everything is written on the first line. Great. So this means that our LCD is ready for us to start coding and to start our coding our code. So first of all, the configuration is done. The next thing we have to do is we have to create the framework. So the framework is the text that will be displayed, but without any change. So the text that will stay constant. So let me delete this block, and we are going to set the position on the LCD first. And then we're going to start with column 0, and row 0. So first bit. And we are going to write time, because on the first row we want to write time, and then let's see how this looks. So let's start a simulation, and it looks like this. Great. So now we have the time. Then we want to be able to put the so we want to be able to put the double dots to put between the seconds, minutes, and hours here. So then we have to duplicate this, the last two lines. Let me place them here, and then uh, please help me. Okay, no. Okay, so the first position we're going to take is the position 8, and then we are going to write only 2 dots, and then we are going to take this and duplicate, duplicate, and then we're going to place this at position 11. Okay, let's see how this works. So now we can put here minutes, seconds, and hours here. We just leave one open slot for the time, so that not everything is quite crammed up there. Okay, and then we want to write on the second column, so row 0, row 1, column 0, we want to write days so that we can measure the days here. Great. And let's see how this looks. Perfect. Good. What we also need is some variables. So we can store the seconds, the minutes, the hours, and the days. So we can click here on variables. We have a create variable option. So let's start with seconds. Then we can create minutes. Then we can create hours. And then we can create days. Great. So now we have we have variables. Let's start by setting all the variables to a fixed value because at the moment they are somewhere they don't have a clear value to them. So let's set the days. We can start with seconds. So we set the seconds to 0. We set the minutes to 0. Then we set, now let me move this a bit lower. This is going to be quite long. Then we set the hours to 0 and we set the days to 0. Great. So now we have the setup completed. We know what to do at the startup. We create this blueprint for the code, and we initialize all the variables with a fixed value. In our case is 0. In later in the video, I will change some of these variables so that we can better understand um, how this works and to do some testing here because testing is quite important. Okay, so next what we're going to do is we are going to start with the seconds. So seconds will be the part that will change the most. And then for the seconds, because we were going to have two digits here. We cannot write here like 1 second, 2 seconds, 3 seconds, and at 10 seconds it appears 10 here. We have to start here 1 second, 2 seconds, 3 seconds, 10 seconds, then we start with a 1 here. So first what we have to do is we have to create an if else statement, and in this if else statement here we have to put the condition for this if else statement, and we're going to put the following condition. If seconds, I'm going to take the variable if seconds is smaller than 10, so this is like 8, 9, then we want to write these values. So then I'm going to set the position for the seconds. So no, not change. I'm going to set, duplicate this one. Oh, it duplicated a lot. Okay, let me remove this, delete block. Okay, now we set the position on the LCD. So we can write on, if this is smaller than 10 seconds, we start with column 12. And then we can write here the value 0. So this is for the first value, which is 0 because it's less than 10. And then we're going to write in column 13 the value for seconds. And here we can have duplicate and just put here seconds. Okay, okay, okay. If this is not true, then we're going to write in row 12, and let me put also the row here. The row is row 0 because we're writing only on the first row. So then I'm going to take this, duplicate it here, and I'm going to write, if this is higher than 10, we're going to write on column 12. Great. That is great. The next thing we have to do is to insert a weight. So the weight is here in the control, here we have to insert the wait feature. So after we set this, we wait 1 second. And then I'm going to put another wait here. Great. Okay. The next thing, so we've displayed this. The next thing we have to do is to update the value for the seconds. So in this case, we have to change the seconds. So after this is run, we have to change seconds and increase it by 1. So to change something, you just go here to variables, change the variable by a value. This value here is going to be a sum between two variables, and it's going to be 0 because we're just increasing by 1. So let's see how this works. Maybe I can, yeah, let's see how this works. So we can see now we're showing the seconds 03, 04, 05. Okay, that is great. And this means that we have finished the seconds feature. The next thing we have to do is, yeah, what would happen, for example, if we go over, yeah, let me put this in milliseconds, just that we do some testing in our development process. So I've put 100 milliseconds. So 1 second is 10 times 100 milliseconds, and see what happens. So now it goes up, up, up. And when it reaches 60, it will go over 60. So yeah, and this is not what we want to do. So now what we want to do is to put a if statement. Okay, so if this reaches uh, the value of 60 seconds, let's go to, if this is smaller, uh, if this is higher or equal to 59, so let me put seconds here duplicated. If the seconds is higher than 59, of course we have to reset it. So then we go to variables, we have to set seconds to 0. So now we are just resetting it. So let's run this fast simulation to see if it resets, and it should reset at 60 here, go back to 0. And yeah, at 59 it goes to 0. So this is great. This means that we are set to reset the seconds. Next, what we have to do is we set the seconds, but we have to increase the minutes. So then we have to change the minutes and increase them. Go to math, take a module of a summing module, and we have to increase it by 1. Great. Then if the minutes also, because then the topic is, okay, we're increasing the seconds, now we have to do the same feature for the minutes. We have to put an if statement here. Okay, what happens if, let me delete this, delete. Okay, if minutes, what happens if minutes goes above 60? So then we go to the math, and then we add here if minutes goes above or equal to 60. So here it's 60. Then we have to set minutes to 0. Let me set minutes. Yes, set minutes to 0. And we have to change the hours. So now we have to change the hours because 1 hour has passed and we have to increase the hour by 1. And the same thing to the day. So we go here, we take day, we delete minutes. So if we've put 4 seconds, we've put 4 minutes, and then we put for not for days, for hours. We have to add 4 hours. If the hours are greater than 24, then we have to set hours to 0 and change days to +1. Okay, so now the incremental feature for everything is done. Here, all the logic for the software is here, how we are incrementing this. Now we just have to display it. So this means that we will create a um, if else. Just let me put if. Okay. So then we have to do the similar thing that we've done for the seconds. We have to do for the minutes. So if let me delete this. I'll copy the whole duplicate. Not that much. Okay. Let me do this and delete, 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 and delete. And now we have only the if else statement. So if minutes, because we're doing the same thing as for seconds now, we're just displaying the we're just displaying on the right square here. So the minutes have to be placed, let's say, in column 9. If they are above, the 0 has to be in column 9 if they are above, they are below 10, and in column 10 we display the value. And here I will duplicate. Okay, it didn't like this. Then I will remove the seconds from here, delete block, and put minutes. Okay. And then here we are going to put the minutes. If they are higher than 10, then we're going to put them in the right positions. Let me place this also here. So this means that if the minutes are under 10, they're going to be placed on column 10. And if they're above 10, they're going to be placed on column 9. Let's see how this works. Just before we go into, so you can see now the seconds are increasing. Maybe just I could reduce the millisecond timing for this, just that we do a faster testing. So the seconds are increasing here, and then the minutes will increase, and we can start with, maybe we can start with 9 minutes, and then let's see if this goes to 10. So 9 minutes, and at 10 minutes it should start here with a 1. Yes, it works. Good. Now we have to do the same for the hours, and then I'm going to duplicate this, place it here, and then replace minutes with hours. Delete this, delete block, hours, and then hours here. Okay, and delete block, and now we are going to be writing on row 6 put a 0, on row 7 the value, and on row 6 if we have 2 digits. Okay, great. So this means that we are done with the why is this wait here? Okay, it copied also the waiting time. Now we have to delete this. Delete block, and delete block because we already waited here. In the seconds where is the only place we're waiting. We're not waiting here when we're displaying. We're just sending it as fast as we can to the display here. Okay, and the last but not least, let us display the days. So I'm going to take this, duplicate it, and for this I'm going to put the row to be 1 and column to be 8 here, so that we can display the days. And what we want to display is days. Great. Now let's start the simulation and see how this works. Okay, so this is quite hard for the days to increase now. So let's do a bit of a tweaking, and we can put here stop coding. We can put like 59 minutes and 23 hours and I don't know, 40 seconds, but this would be, let's put 0 seconds here just for testing purposes, and let's see if the day increases. So yes, the day has increased here. Okay, and let's say this has been running for 100 days. Let's see if this works the same. 100 and 101. Okay, so this was a short tutorial on Arduino and on 2 times 16-digit LCD display. I would like to build this project also in a physical state so that I can, yeah, it's much easier to understand it also physically as it's working. Hope you like this project, and yeah, if there are any questions or you need any support from my side regarding understanding the functionality of the software, including the coding for this, so I'm just going to show it again and maybe also explain it a bit. So first we display the parts that are not changing from the LCD display in the on start function, and in the forever, in the loop where we're constantly looping through, we display the we start by displaying the seconds that have a waiting time. Now the waiting time, if you want to make this like real clock, we can put here 1 second um, because it's a more realistic design. And um, here then we do the if statements. How do we increase from one side to another? So from seconds to minutes, from minutes to hours, from hours to days. And then on the last side, where we display each of the bits, where if they are less than 10 digits, we display them on the right digit. If they are less than 10 bits, we if they are higher than 10 bits, we display them here. So we either display them on row 9 or on row 10. From it's just a selection here. Hope you like this video. Looking forward to hearing about your experiments in the comment section. Wish everybody a great day.